Why is the psychrometric chart essential for air properties? Have you ever wondered how engineers determine the comfort level of indoor spaces? The psychrometric chart plays a vital role in this process. It is a graphical tool that illustrates the physical and thermal properties of moist air. Understanding these properties is key for designing effective heating, ventilation, and air conditioning systems. The chart combines several important air properties into one visual format. These include dry bulb temperature, wet bulb temperature, relative humidity, humidity ratio, dew point temperature, and enthalpy. Each of these properties impacts how air behaves in different conditions. Air is rarely dry. It usually contains water vapor. This moisture affects comfort, energy consumption, and system performance. The psychrometric chart allows engineers to plot these properties together, making it easier to analyze processes like heating, cooling, humidification, and dehumidification. In practical applications, the psychrometric chart is used in several ways. First, it helps determine cooling and heating loads. By plotting indoor and outdoor air conditions, engineers can calculate how much sensible heat and latent heat need to be managed. This ensures that indoor spaces remain comfortable. Second, the chart is useful for analyzing air treatment processes. It visually represents how air changes as it moves through HVAC components, such as cooling coils and humidifiers. For instance, it shows how cooling air below its dew point leads to moisture condensation, which is essential for dehumidification design. Third, the psychrometric chart aids in optimizing system performance. By understanding the relationship between air temperature and moisture content, engineers can select and control HVAC equipment more efficiently. This helps avoid overconditioning or underconditioning spaces. Fourth, it assists in troubleshooting and designing systems for various climates. Since air properties change with climate, the chart helps engineers create systems that respond effectively to different outdoor air conditions. This ensures energy-efficient operation. Lastly, the psychrometric chart simplifies complex calculations. Instead of relying solely on equations, engineers can use this visual tool to reduce computational effort and minimize errors. This makes it accessible for both engineers and technicians. Key terms to know when using the psychrometric chart include dry bulb temperature, which is the actual air temperature, and wet bulb temperature, which indicates moisture content. Relative humidity shows the percentage of moisture in the air compared to the maximum it can hold. The dew point is the temperature at which air becomes saturated, and enthalpy is the total heat content of the air. In essence, the psychrometric chart is a fundamental tool for mechanical engineers working with HVAC systems. It integrates multiple air properties into one visual format, enabling precise analysis and control of air conditioning systems. This ultimately helps engineers create comfortable and energy-efficient environments.